parameter. So the address of that object is going to be stored on the stack, right?
Yeah, that's it. Yes, yes.
And so if we return
So
the object again,
the value. So whatever is the value of that variable? Yes.
no,
So in this
I'm saying
case,
about,
the value is a pointer to the address.
okay, yeah. Yeah. Thank you, sir.
So yes, so I did start the recording, and let us wait for a couple of more minutes, maybe a minute more, and then we can get started. So the plan for this lecture is I'll complete the set of slides which we started in the last lecture. So this was on classes and objects, and I'll get started with the next set of slides, which is on the relationship between the classes. Okay, so let me just briefly review what we have seen in the last class, and then I'll get started with the next set of the next topic, right? So in the last class, we looked at these sequence diagrams. So how do we identify these classes and the methods? So we look at these nouns, which can potentially be a class, and then the verbs, which can potentially be a method, right? And then we talked about the responsibilities. So the good practice here is a class should not have too many responsibilities, and whatever responsibilities that it does have, so these responsibilities are captured in terms of its methods, right? Because methods are the ones that do the actual work. So the state is represented in terms of the attributes, but the work of changing the state or doing any other task is up to the methods. So the method should be cohesive. That means they need to be related to each other, and there should not be too many responsibilities for one particular class. So those are the things that we talked about. And then we also talked about these objects as parameters. So we looked at constructors. So we can use constructors to instantiate the or initialize the values of the attributes, right? Attributes are nothing but the class data, or the instances of the class. Okay, and then we looked at this example where we can pass in the object as the parameter, right, for a class. Sorry, for a particular method of an object. So that is where we stopped last time. So this was an example of how one of the, so we created this Django instance, which is an instance of the dog, and then we passed that from the pet shop, right? If you remember that. So one of the methods in the pet shop calls the groom method, and it passes the Django object. But on the other end, on the groom side, on the dog groomer side of things, so there's a parameter that takes in that value, but now the name of that parameter is Shaggy Dog. So Shaggy Dog and Django, they refer to the same memory location, which we will see in this class, right? So that is all we have discussed in the previous lecture. So if you have any questions, we can spend a few minutes on those questions. If not, I'll go ahead with today's lecture. So are there any questions from the last class?
Excuse me, sir.
Yes.
So I had a question regarding the last slide. When we pass an object as a parameter, let's say this is in reference with a question that was asked to us in the refresher lab also. So like in C++, an array is always passed as a reference.
Okay.
But in Java, it's not passed as a reference. It's passed by value. In the sense, like if I make a change inside an array, inside a function to the array, it won't be reflected outside the function.
Okay.
So does that happen with objects also?
Okay, so there is this, okay, we haven't yet come to that stage, right? But generally in Java, it is okay, like you said, there are multiple ways of passing these parameters. One is by reference value, and then there's something like called name, so which we don't discuss here. So let's say in C, there is an explicit way to pass a parameter by reference. There's an indicator, like you can use this ampersand, for example, and then you can indicate that, okay, now we are passing this parameter by reference. So in Java, everything is by name, sorry, by value. Even the reference is passed by value, right? So what we mean by that is, so if you pass a reference like Django here, so here you are using the Django, and then in the next slide, oh, where is that? I thought there's somewhere you have Shaggy, right? Where was it? Yeah, so here you take in that parameter with the name of Shaggy. So um, so even though you pass Django, you are not passing it uh, by reference. So the reference is passed as value in the sense that, let's say Django is stored in memory location 1001. So the 1000, so Django is a uh, name given to the location called 1001. So whenever you pass Django, you are passing the 1001 and not the uh, actual content that is in 1001. And let's say if you replace Django with a basic data type, which is, let's say, integer, and now if you are passing integer which has value 5, then whatever value is in that variable, which is 5, gets passed. So there is a minor difference, but in the end both are passed as value. Right? So in the case of Django, it's 1001. In the case of, because that is what is that's what represents Django. And in the case of, say, age, you pass 30 because the value of age is 30 here. So
Okay.
yeah, in that sense, it's everything is by value.
Yes, sir. Thank you so much, sir. So, like in the sense, if I make a change to that object inside the function, so it won't be reflected outside then.
No. So since we are passing the reference also as value, right? So in the end, reference is getting passed, but it is getting passed as a regular value. That's it. So you still have the pointer to the memory location. Right, so maybe, okay, so we'll be talking about these memory locations in the next couple of slides. So maybe wait for a couple of more slides, and if that doesn't answer your question, we can get back to this question.
Thank you so much, sir.
Okay, so yeah, let us talk about these memory locations, right? Okay, so when we say memory, we mean the RAM, so to say, not the permanent space, which is like the hard disk, or let's say your USB devices, but it's more of the system memory, which is the RAM, right? So which is a temporary memory. So once, let's say, whenever you shut down your machine, all the things that are there in the RAM get lost, right? Or when you stop the program, then again all the things that are there in the RAM, they get lost. So we are only talking about this system memory, which is the RAM part. So that's what we mean by the term memory here. And for the sake of discussion, we can think of memory as a list of slots. So now we don't here discuss or care about what is the size of each slot. So each slot can be of any granularity, right? So, but for the sake of discussion, we just take it as a slot. So it can be 4 KB or even less, say 1 byte. But for the sake of discussion, we just treat it as a slot, and we don't worry about the amount of space each slot takes. Right? So that's, so in some ways, so this is an abstraction, right? We are not worrying about the underlying details. Okay. And then we discuss the memory that in terms of this example, which is the pet shop example that we have been looking at it for the past couple of slides. So pet shop, there's a class called pet shop, and it has the constructor. And in one of the methods, which is called test groomer, there's an instance of dog that we create. One is called Django, and then there's an instance of the dog groomer class that we create, which is called the groomer, right? So now let us see what happens in terms of the slot allocation or the memory allocation. So somewhere in the memory, you have this list of slots. This is the memory. And then let's see what happens whenever we create these new instances and pass them or make these method calls. Right? So let's see whenever we create an instance of dot, so somewhere it will create it will request for a slot from the operating system, and it will get the slot. Let's say this is again 1001. Now Django refers to that particular slot, so it's a name given to a memory location, right? So 1001 is now referred to as Django. So yeah, to refer to this. So this is already. So now let's go to the second call here. Sorry, second instruction, which is creating an instance of the dog groomer class. So again, the same thing happens. So it will request, because of this new keyword, it will request for a memory location, which is free. Once it gets the memory location, it calls the constructor, initializes everything that is part of the constructor, and then it will name this memory location as Groomer. So let's say if this is 1000. So 1000 is now called as Groomer. So now we go to the third sentence, which is a method call. So in this method call, we are passing in the parameter called Django, and this is the same method, right? So this method gets called, and in this case, okay, we have the groomer, which refers to this one. Django refers to this location. And now let's go ahead and look at what happens here. So this is the method call, and this is where it comes in for the execution. And the first step is to assign a value to Shaggy Dog, right? So now Django is nothing but Shaggy Dog, because okay, so here Django refers to 1001 memory location. So that value is passed in here. So Shaggy Dog also refers to the same memory location, which is 1001, right? So now if Shaggy Dogs makes a change here, then it also gets reflected in Django, because both are now referring to the same memory location. So in that sense, they are an alias of each other. So yeah, that's. So you can pass in any instance, obviously. So Django 1. So let's call this Django 1, and later on you can also pass Django 2. So whenever groom gets called with any particular object, let's say Django 1, Shaggy Dog refers to Django 1 until the end of this method. And once the execution goes back here, and then there's a fresh call of groom on Django 2. Now Shaggy Dog refers to Django 2, right? So we discussed that here. So let's say we want to reassign. So initially we assigned a new instance to Django.
Sir?
Yes.
Sir, instead of passing an instance of any class, if we just passed a primitive type, so will the changes be reflected?
No. So in that case, so let's say you passed in Django.age. So here it will be an int age, for example, and you are making a change. So initially the value of age is, let's say, 5, and here you are making it as 7. So when you come back here, it doesn't get reflected, because it will create a copy of that variable, right? So it's
basically in the primitive typeset, it is always passed by value, and in the instances, it's always passed by reference.
So for the sake of understanding, yeah, you can treat it that way, but it is always passed by value if you look at it, right? So here, what happens if you pass age is that value 5 gets copied to age here. So let's say there is Django.age. So currently it refers to 5. So you pass that, and here it's int age, and the value of 5 gets copied to age, right? So if you change this particular variable, there is no change because it's a copy. So here the same thing is happening. So here you pass Django. So the value of Django is 1001, but instead of a regular value, it happens to be a memory location. So you again, same thing gets copied. So Shaggy Dog has now has 1001 in its as its value, but it's just that it happens to have a reference, right? So if you change something here, it will get changed because it happens to have a pointer to a reference. So in that sense, everything is passed by value. So what they say is reference is also getting passed as value. But in order to simplify the understanding, you can take it the way you specified, right? You can, the way you said. So you can say that primitive types are passed by value, but these are passed by reference. But like I said, that may not be the right way to portray the thing. So you can just say everything is passed by value, including the references.
Hello.
Yes.
Yes, sir. I had a doubt. So how are Django and Shaggy Dog pointing to the same memory location? Is it because of the method?
No. So yeah, so like I said just now, right? So Django, so when you create a new instance of the dog, Django is pointing to this particular memory location. So it's just a name given to a reference, sorry, name given to a memory location. So let's say this is 1001. So Django now holds the value of 1001, but it's just that 1001 happens to be a memory location. So now if you pass Django to this one, you are passing the value of the memory location, which is 1001. So 1001 comes here. So Shaggy Dog refers to the same 1001, which happens to be a memory location. So now there are two names given to the same memory location.
Okay, sir. Thank you.
Okay. Yes, are there any further questions?
Sir,
Okay. Yeah. Yeah.
I was asking, like, we are passing that object as a parameter, so it is not getting copied. It's just like it is passed by reference.
The reference is passed by value.
So sir, basically you mean that the primitive types are passed by value and everything is passed by value, but like the Django, this is a reference. It is also being passed by value, but it happens to be a memory location. So whatever change we will make in the Shaggy Dog, it will be reflected in the original memory location as well.
Yes, that is right. Yeah, that is exactly right.
Okay.
Okay.
So here we are considering like in case of Java, how Java functions. So we consider arrays to be primitive data types, something like that, because arrays, this is for a fact, arrays are passed by values.
Okay, so in Java there is a class called array list, right? So to say, I don't know if you are referring to that array.
No, sir.
So
I'm talking about I'm talking about the array, like int square brackets a, something like that. Yeah.
Okay. So and you want to pass that as so you are passing that as parameter to a method, is it?
Yes, sir.
Okay, and then in the other method, you are changing the value of the array.
Yes, sir. I'm changing one of the indices. Let's say I'm incrementing one of the indices by 1.
Okay, so in that case, yes, I don't think it will be it will reflect. So there is something called an array list, so which happens to a class. So generally, when you want to build an array, let's say, you can specify the data type also. So you can say array list of integers and array list of whatever, double or string or whatever, and it will take that. So if you want to use arrays, you should, I think generally we end up using that one, and that one acts as a regular any other object, right? So you can treat array list array A1, for example, and then create a new array list. So it acts as an object, but that object can now store multiple values of integers. So in that case, it will act as a regular object, and if you change something there, and it will get reflected again. But in this case, it wouldn't. In the case that you said.
So in Java, the arrays, the changes are reflected. I've tried that.
So let me.
But I don't know why, because like in C++ it happens that the name of the array is the pointer to the first element of the array. That's why it happens like that. I am not sure about Java, but the changes are reflected.
Okay, so okay. So why don't I post an example? Right,
Yeah, you could confirm why that happens.
Yes,
Yeah.
so why don't I post an example and post an explanation also on the classroom?
Sir, could it be the reason that when we declare an array, we write as new int and then brackets? So when we write new, it's actually making a space in the heap.
Yes.
So that's why the array variable contains a reference and not a primitive type. That could be a reason.
Yeah. So that's a good explanation, right? So I would have said the same thing. Yes. So so if you are creating it using new, then whatever you said is right. So we are creating a space. We are acquiring a space on the heap, and the same thing that is happening here would also happen there. So we are requesting some memory space, which, for example, if you ask for new of say int 10, so 10 integers, so then it will ask for 10 different slots, and then it will pass on the memory reference. So in that sense, yes, you are right. So it should. So if you pass in the value of that integer array, then it will get changed. So as long as so the thing I guess to remember is, as long as you are creating a new memory, right? Like using this new and then asking for memory, and then it will always be a reference to that particular memory location. And then if you pass it somewhere, there is always this reference that gets passed, and you can change or there's a possibility to change in the method call. Right? Does that help? So I'll also post an example. Right? I'll may make a small example and then post it on the class. So shall I move on? Are there any other questions? Okay, so let me move on. So there's also a possibility of reassigning these names, right? So for now you have called the new instance as Django, but you can create one more instance of dog and call it Django as well. So in that case, the old Django, the reference to the old Django no longer holds, right? We can't remember that. So in that sense, you can reuse it, but you will lose the reference to the old one. So let's take a look at that case. Okay, I thought there was a memory location as well, but okay, I think it will show up in next slide. So here we have created a new instance of dog and called it Django. So let's say here the memory location that it refers to is 1001. So, but later on you want to groom a second dog, a new dog. So you are again creating a new instance, but you are using the same name. So let's say 1002. So this new instance is stored in 1002, and now Django refers to 1002. But now we have lost the connection with 1001. Right? So there is no way to retrieve the information of the previous instance. So if you want to retrieve that information, then you need to store it in a different variable. But if it's not required, you can always let it go. Right? So so we'll be looking at it here. So let's say you have created a new instance of the dog, and the name of that location, let's say it is 1001, and your Django is now referring to 1001. You also have created the groomer, and you call the method, which the details of which we will skip. But here you have created one more instance of the dog, but you have assigned it to the same name, Django. Right? So now Django refers to the new memory location, this one. And it would have lost the connection with this previous location. Right? So there is a term called, concept called garbage collection, which we'll be looking at it later on. But basically what it does is, if there is these unused memory locations, so to say, or the connections have been cut, and there's no way to refer to this, right? So in that sense, it has become unused, and so since it has become unused, the runtime environment would automatically reclaim this memory location. So let's say you have created one more dog instance, then the same memory location could be used there.
Sir, I had a doubt in this concept.
Okay, but there are techniques on how this garbage collection happens, which we look at in a couple of other lectures. Right? Yes. So yeah, what was the question?
Yeah, sir. So suppose in your Groomer class you have an attribute which is an array list. It stores all the dog objects that you're, giving to the Groomer, right? So let's just suppose in this test Groomer method, we created this dog Django, right? And then we pass it to the groom method, where it adds that dog to the array list. So when you're passing that, then in that array list, the first element of that array would be pointing to the same memory location as Django is, right?
Yes, yes.
Then we reassign Django. We do this Django equals to new dog. So Django no longer points to that memory location; it points to a new memory location. But that the older memory location will still be pointed to by the array list, right?
Yes, yes.
Okay, so obviously it wouldn't be collected by the
no,
garbage.
In that case, it's not garbage collected, because there's at least one reference that still points to this old location. So yeah, in that case, it won't be garbage.
Okay, sir. Thank you.
Okay, so now when you call the groom method on the Django, so this particular memory location would, this particular instance of the dog and the memory location would now be passed to the groom method. Okay, so that brings us to this concept of local variables. Right? So there is this concept of scope for any variable. So scope defines what is the region in which it can be accessed. So here Django is a local variable. So it's called local because the scope is restricted to this method, within this method. So once you go beyond this method or outside of this method, you can no longer refer to Django or Groomer. Right? So in that sense, the region in which, or the block of code in which it can be accessed is just the test Groomer method. It starts from here and it ends here. And once you come out of this method, you can no longer refer to Django or Groomer. So this also is applicable for method parameters. So let's say test Groomer has one parameter, and if the value of this parameter for test Groomer can only be accessed within this method. So if you go beyond this, then you cannot access the parameter. So this is an example of it. We'll come to the example in the next slide. So there is this Django again and Groomer, which are local parameters or local variables. So once you go beyond this function, they are no longer, they cannot be referenced again, right? So there's no way to use Django or Groomer. Since you cannot use them, they can as well be removed from the memory location and it can be reused. So again, garbage collection comes into play here. Garbage collection is nothing but reclaiming the memory that is taken up by these objects. Right. So again, like I said, so we'll be looking at the procedure later on, but so the C equivalent is the delete. So you have the new and delete. So using new, you can create, you can request for a memory location, right? And using delete, you can say that now you want to release the memory. But in Java, you don't have such fine-grained control over releasing the memory. So you can always request for memory using new, but you cannot say that you want to release some memory. So the only way, so that is done automatically, and that's why the that is one of the nice features, right? So it relieves the programmer or the programmer from that responsibility. So there are lesser errors in terms of the memory references in Java than when compared to, let's say, C or C++.
Sir,
So,
are there any destructors in C and Java?
No, there are no destructors, at least in Java. So since there is no concept of class in C, there are no constructors, destructors. But in C++ you have destructors.
Sorry.
Yeah, in C++ you do have destructors because it's it is built on top of C, right? So it's object-oriented version of C. So in that sense, whatever you can do in C, you can also do in C++. So yeah, you can have destructors and you can release the memory in C++. But in Java, there are no destructors. So you can later on when we look at this garbage collection, you can always request for the garbage collection. But whether the request gets honored or not is up to the runtime. Right? So it may ignore your request for garbage collection, and sometime later on during the program execution, it might feel that okay, now there is a need to recollect some of the space, and it might start the garbage collection. So it's up to the runtime to do the garbage collection here in Java.
Okay,
Sir,
sir.
Yes.
So in the previous slide, could we have written public doc Django equal to new doc to make it a globally accessible variable?
Yes. So yeah. So globally accessible meaning there are a few ways, right? So one is accessing it within the class, but beyond this method. So in that case, you can make it as an instance variable. So the other possibility is accessing it even outside of this class. So for that, you can change the visibility modifier of the instance variable to public. So if you make the variable as public, then it's available even outside of this class, right? But if you create it as a private one, then you can access it outside of this method, but within the class. So those are the two possibilities, which we will be discussing here.
Okay.
So, so let's say this is an example, right? So let's say you created this variable here, Django. So this is a local variable to the constructor. So you created in the constructor, but you now want to use it in the other methods also. So the scope of this Django is restricted only until the constructor. So, but if you want to use it in the other methods, it is not possible, and you will get an error, something like this, right? So it says that the variable Django is unrecognizable. It doesn't know what Django is here. So to get around that, we can use the two techniques that I just discussed, right? So which we also look at it here. So one is, you can make it as an instance variable, but it can have two visibility modifiers. So yeah, we can get back. Let me show that example, and then I can. So one is that you make it as a private one, and so if you make it as a private one, then this particular instance is now accessible to all the methods in this particular class. So you can use Groomer in the constructor and initialize it. You can also use Groomer in the other method, but you cannot use it beyond the class. So you cannot use it, for example, outside of this class. The only way to use it would be through, again, the public methods. So if you have a setter and a getter, then you can use it. So the other option is to make this as public. So if you make it public, you can use the Groomer directly outside of this class as well. So for example, you can say pet shop 1.groomer directly, but that is a violation of the encapsulation policy, right? So encapsulation generally you only interact through these public interaction points, and generally it's a good practice to have getters and setters for these kinds of instance variables. So yeah, so to increase the scope, you have to make it as an instance variable or the variable of the particular class. So generally, you can now let me go back to this previous slide. So generally, you need to make all such variables as instance variables, which can model the characteristics of a particular class, right? So, for example, you have the pet owner, or sorry, pet shop. So, pet shop can have different characteristics, like the number of animals that the pet owner has. The pet shop has, the location of the pet shop, the timings of the pet shop. So these are the characteristics that are common across all the instances of the pet shop, right? So those are good candidates to be made as instance variables. So instance variables are nothing but attributes of the class, which store the state of the class, right, of the object. So in this case, in the case of the dog, for example, you can make the breed, name, color, age. So all these things can be the instance variables for that particular class of dog, right? So instance variables can be either basic data types like int, float, and so on, or they can be custom data types or user-defined data types like classes. So you can also have, so we had the test groomer, for example. Test groomer can be an instance of the pet shop. Yes, so yeah, we already covered this one. So are there any questions so far? So like we discussed earlier, these instance variables are what capture the state of the object, right? So if there is an object of pet shop, the state of the object is captured in terms of the values that are assigned to these particular attributes. And you don't call the values of local variables as part of the state. So you don't consider that to be a state of the object because they are local, right? So once you come out of this method, the values of those local variables no longer hold. So they are not part of the state of the object. So only the instance variables are part of the state of the object, right? So the other important thing is to initialize all the instance variables in the constructor. So here we have created one instance variable, which is the groomer, but we have not initialized it. Right? So if we don't initialize it, there is always a default value. So for the int, for example, it's 0. If it is a string, it's an empty string. Okay? And for an object, it will always be null. So if it is a custom defined data type or a user defined data type, then it's always a null. So null is a special value. It's a keyword and it's a special value indicating that so it currently points to nothing, right? So ideally this should be a pointer to a particular memory location on the heap, as we discussed. But if we don't assign any initial value, like if we don't create this new dog groomer, then the default value will be null. So null indicates that it's not pointing to any memory location, right? And that can land you in trouble. So for example, if you don't initialize this groomer class, groomer object, and then you call this something like this dot test groomer, and within the test groomer method, you are referring to this groomer variable, right, or the instance variable. So now groomer currently has just the null as its value, which is no memory location. So since you don't have any memory location, it will result in what is called as an exception. So exception is a runtime error, right? So whenever, so this is not a compilation error. So it is a runtime error. So when you run this program, since you have not initialized it, but you are trying to use that, it has null and it will result in an error. So the program would stop abruptly if you don't handle it. So again, we'll be looking at these exceptions at some point of time in the future lectures. But think of it as error, right? An error that happens at the runtime. And there are some names given to each exception. So in this case, it's called null pointer exception. And there are multiple different types of exceptions.
Excuse me, sir?
Yes.
Sir, you just told that string just gets initialized to a blank string. Instead, it gets initialized to a null value.
Oh, is that so? Okay. Okay, so that can be explained. Um, so string is actually treated as a class, right? So it's treated. So whenever you say string name, for example, so name is an object and string is actually a built-in class, right? So in that sense, whatever you said is right, and yeah, whatever I said is not correct, right? So it should, because all objects of any class, they are initialized to null. So in that sense, even string, it applies to string as well. So the only thing that is different with strings is you don't have to say new string, although that is also possible. So you can also say it as string name equals new string of, say, John, or you can directly assign John in double quotes to the name string name. So that will also that is also okay. So there are now two ways to create these strings. Yeah, but you are right. So in either case, you are creating a new instance of string and assigning it to.
So when we use a new operator, then it gets initialized, then it gets initialized with a blank string.
Then you, unless you are explicitly calling it with a blank string, right? So for example, okay, there is a whiteboard, but okay, let me just use this. So let's say you have string name. You can do it in multiple ways. You can say string name equals John, or you can say string name equals John as well. Or if you simply say string name equals new string, yeah, then in this third case it will be a blank string because you haven't passed anything, so it defaults to blank. In the other cases, you are initializing it with something else, some specific value. But string, like I said, is a built-in class. So if you just say,
sir, if you're typing something, it is not visible.
Oh, it is not visible. Oh, I thought since I'm sharing the entire screen. Okay, so I'm typing it in the chat window actually. Okay, let me use my text pad. So is my text pad visible?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So there are now multiple ways, right? So perhaps we'll look at it in some future lecture. But again, there are, so string, as I said earlier, it's so this is a built-in, one of the built-in classes which you can use. So similar to array list, right? So it's a built-in class. Now there are multiple ways of initializing it. So you can either say new string of John, or you can simply say string name equals double quotes John. And in this case, it initializes to an empty string, which was what one of you were asking about, I think. And in this case, if you don't initialize it, in the case similar to other objects, it will be a null. So yeah, so you are right. So whoever the student who asked that question, that is right. So it will be null here, right? So yeah, does that answer your question?
So can you explain that again?
Yes, sir.
I couldn't understand.
Okay, so the question was, so some couple of slides back, I said there is always a default value for each data type. For int, for example, it's if you have int age, these are all consider them as instance variables of class. So there are always default values associated with each data type for instance variables. So for integer, for example, it's 0. For string, I said it's empty, but one of the students said that it should be null, which is true, right? So because the reason behind that is string is, say, built-in class or built-in data type. You can also say that, but it's a class, right? So for any class, if you don't initialize the object of that class, it's always null. So in that sense, even string should have a null as the default value if it's an instance variable, right? So now I just went through a couple of options of initializing strings. So you can either directly say string name equals John in double quotes, whatever is the string value, or you can, if you want to give it the empty string, so you can either say give the empty value or just say new string and don't specify any value in the constructor. So the other way to assign again the value for string is using the constructor with the name John in it. So those are the different ways of creating strings. Sorry, was there a question? Your voice was not clear.
Actually, so in the fifth statement of a text file, you wrote string something is equal to blank string or new string. So when you write string name is equal to new string, it by default sets an empty string or a null string.
So in this case, if it's just double quotes with nothing in it, then it's an empty string. So it sets it. Sorry, it sets it to empty string.
And instead, if we write a new string, it sets an empty string or a null string.
Yeah. Empty string.
Okay.
So null, there is nothing like called null string, right? Null is just a
null string exactly. So, but I mean, does it assign it to some memory address or not when we?
Yeah, it does. So, okay. New, whenever you say new, automatically a new memory location is created and assigned to it.
Thank you.
So this is implicit. So both this procedure, this way of calling it, and this one, both are equivalent. So even here, there is a new memory location that gets created, and the value that is put in is John. Okay, so let's get going. So this is the, so this results in the null pointer exception, right? So since you have